In this video, I'd like to talk about the math question of the day for Saturday, July 1st, 2023. And with this problem, we're given a function and we're asked to find the line tangent to this function at an x value of 2. And finding tangent lines to functions at specific x values is something that's typically taught in a Calculus 1 class. So at this point, go ahead and pause the video, see if you can work through this on your own. And when you're ready, unpause the video and we can go through this together. Now, assuming that you have attempted the problem, let's start working through this. And finding tangent lines to functions at specific points involves finding the derivative of the function. Since, let's say we have some random function, which we can maybe call g of x. And if we want to know the tangent line at, let's say, an x value of 2 for this function, we're looking at this point on the function, and we want a line that is tangent to that, so something like that. We want to know the equation of this line. And to find the equation of the line, we need to know a point on the line, which we can figure out by just plugging in 2 to our function. And then we just need to figure out the slope of the line. And remember that the derivative of the function, the rate of change of the function, tells us the slope of the tangent line at any given point. So if we can find a formula for the derivative, we can plug in our x value of 2, and that will tell us the slope of the line that's tangent to the function at that given point. And then, like I mentioned from there, we will also need the coordinate point that the tangent line touches the graph, and from there we can just use point slope. We can plug in our known coordinate point and we can plug in the slope and solve for the equation of that tangent line. Now, I should mention this is just a random function. This is not this function f of x, but this gives us an idea of the process for what we're trying to do. So we want to find the derivative of this function, f prime of x. And before we start going through that process, let's rewrite this square root as 2x to the 1/2 power, since then it will be simpler to take its derivative. We have minus 6 multiplied by e to the 2 minus x. And at this point, we can take its derivative, f prime of x. We'll need to use the chain rule here. And remember that if we have some function k of h of x, a composite function, and we take its derivative, this is equal to the derivative of the outer function with that inner function unchanged, multiplied by the derivative of that inner function. So remember this right here, this is just the chain rule for derivatives. And applying that to this first function, we carry the 4 along since it's a constant, and we bring down the 1/2 and multiply. We're using the power rule. And 4 times 1/2, that's just 2. Then we subtract the exponent by 1, so now we're at minus 1/2. And then we multiply by the derivative of that inner function, which is 2. Now we find the derivative of the second term. Again, the 6 will just carry along with us since it's a constant. And the derivative of exponential functions are equal to themselves. We have e to the 2 minus x. And then we multiply by the derivative of the inner function, this function here. We're using the chain rule again. And this is just a linear function, and the derivative of this would just be -1, since the derivative of a constant is 0. Constants do not change. Their rate of change is 0. And this is minus x to the first. We use the power rule, bring down the 1. So we have -1, and then subtract 1 from the exponent. And we know x to the 0 is just 1. So this right here is our derivative, which we can simplify at this point. Let's rewrite this using our square root notation again. And we can do 2 times 2, that is 4. And this is a negative exponent, so it can go in the denominator, and we'd have 2x to the positive 1/2. And remember, when raising to the 1/2 power, that's just taking a square root. So we have 4 over the square root of 2x. And here we have minus 6 times negative 1, which is positive 6, multiplied by e to the 2 minus x. Now this is our formula for the derivative. This will give us the slope of the tangent line at a given x value. So let's plug in our x value of 2. We can evaluate our derivative at 2. We have 4 over the square root of 4, which will simplify, and then we have plus 6 multiplied by e to the 2 minus 2, which is 0. So e to the 0, that's just 1. Here we have 4 over 2, since the square root of 4 is 2. And that simplifies to 2, plus 6 times 1, which is 6. And adding these together, we just get 8. So this right here, we can call this m. This is the slope of our tangent line. And I also mentioned to find the equation of this tangent line, we also need a point on the curve at that given x value. So we need to know the y value when x is 2. And for that, we can just plug that into our function. So let me make a bit more room here. And now we're just going to evaluate f of 2. And when we plug in x is equal to 2, we get 4 multiplied by the square root of 2 times 2, or square root of 4, minus 6 multiplied by e to the 2 minus 2. So we get e to the 0 again. And this will simplify. This is 4 times 2, which is 8, minus 6 times 1, which is 6, and we get 2. So it looks like at an x value of 2, this function goes through the point 2, 2. So we have a point on a graph, and we have the slope of our tangent line. And at this point, we can just use point slope. So let me write down quickly what we have. We have our point at 2, 2, and we have the slope, which we usually call m. This is equal to 8. And remember that the point slope formula, which can be derived from just the slope formula, m is y2 minus y1 over x2 minus x1. This formula is just y minus y1 is m times by x minus x1. So let's now plug in everything we have. We can label this point as x1, y1, and we know m is 8. So combining everything together, we get y minus y1, which is 2, is our slope, 8, multiplied by x minus x1, which is 2. And we can solve this for y to change this to slope-intercept form. We can add 2 to the other side, distribute the 8. We get 8x minus 16 plus 2. And to finish everything, we get minus 16 plus 2, which is minus 14. So this right here will be the equation of our tangent line to this function at the point x is equal to 2.